So when we left off, we were talking about solutions and how solutions is another word for homogeneous mixture, and how a homogeneous mixture is something that has two or more substances that when they're mixed together, they look the same. Like you can't tell the difference. So for example, coffee, when you mix your sugar and your coffee, you know it has both coffee and sugar in it, but once it's dissolved and mixed together, you can't really see it. It all looks the same. Now, it might not look the same as before. It might look a little more tan than black, but it all looks the same. It's uniform in its appearance. Okay. Now, there are three types of solutions. We have our first one is an unsaturated solution, and this is when your solvent contains less solute than it can hold. So, for example, this would be black coffee. Black coffee has the ability to dissolve sugar, it just doesn't have any in there at the moment. Okay, so it would be an unsaturated solution. If we dissolved sugar in it and we dissolved the maximum amount it would become saturated. Okay, and what this means is that if more solute is added, okay, or more sugar in the case of our um, coffee example, it would not dissolve. It would fall out as a precipitate, or in other words, it would stay a solid. Okay. Now, what I mean by this is let's just get some basic definitions down. Remember, a solvent is what's doing the dissolving. So in this case, that would be the coffee. Okay. The solute is what is being dissolved. Okay. This would be the sugar. Now, if I want to know how I could tell if my coffee is unsaturated or saturated, well, if I have my coffee cup, okay, it's got some coffee in here, right, and I dissolve some crystal pieces, okay, well, if they all dissolved, okay, then that means it was unsaturated. I had not reached the maximum yet. But if I have my cup of coffee and I put some sugar in it and it all falls to the bottom, it kind of sits at the bottom of my coffee cup, it will not dissolve anymore, then I would be saturated. So this would be saturated, this would be unsaturated. Okay, so hopefully that helps you remember the difference. Now, if we want to talk about our third one, which is supersaturated, okay, a supersaturated solution contains more solute than the solvent can normally hold at that temperature. Okay, an example of that is sweet tea. And the way you do it, same way you make sweet tea, is you heat the solution first to dissolve the extra, and then you cool it to a lower temperature. So let's say, again, I've got this gallon of water, okay, or this gallon of tea, and it's at let's say 50 degrees Fahrenheit. It's been sitting in the fridge for a while. Okay, very nice and cold. All right. At that temperature, if I were to just take sugar packets and put it in there, not very much of it would dissolve. So let's say if I put 100 grams in there, only 10 grams would dissolve. Okay. So that would mean not a whole lot. Okay, very unsweet. But if we make the tea, all right, the same amount of water, okay, and instead I let it boil first, that would be 212 degrees Fahrenheit. Well, then if I put 100 grams of sugar in there, all of it will dissolve, okay? So it's all nice and mixed in, and this unsaturated one would still have sugar all up in the bottom of it. So it's all dissolved, there's none in the bottom, okay? And what that means is now that it's boiling, okay, I let it cool down slowly and put it into the fridge. Well, even though it changes temperature, it gets cold, the sugar doesn't all of a sudden come out of solution. It stays in that solution. So it's a supersaturated solution. So another example would be rock candy. If you've ever been to the tourist places where they have a little stick and it's got like a piece of candy on the top, let's say, sometimes they're like different colors. It looks like a bunch of like crystals on the edge, like this. Basically what they do is they take this little wooden stick and they dip it in a solution that has a ton of sugar dissolved. So basically it's just like sugar and water and sometimes a little flavoring, but mostly just sugar water. They dip it in there and then they put it in something really cold very quickly and it automatically becomes a solid again and it crystallizes into the cool looking um, candy that you see. And it's very tasty because it's essentially just straight up sugar. So those are the three types: saturated, unsaturated, supersaturated. Now, a solubility graph is going to be very important because these graphs show the relationship between temperature and the amount of solute. Now, we've discussed how temperature can increase the amount of solute that you can dissolve in a solid. And decrease the amount in a gas. So when you look at these charts, all of these that are showing an increase or an upward slope right here, these are all solids because as my temperature is increasing, my graph is going up. Okay, so that shows us solid. However, this one shows that as my temperature increases, my line is going down. So that would mean this is a gas because negative or downward slopes are gases. Okay, but how to tell if I'm looking at a saturated, unsaturated, or supersaturated solution? Well, let's take calcium chloride for example. Let's say I'm at 20 degrees. Okay, if I'm at 20 degrees and I have 60 grams, okay, this would be unsaturated because I'm under the curve, okay? The curve represents the maximum amount you can dissolve at any given temperature. So at 20 degrees, the maximum I can dissolve is about, let's say, I don't know, 77. So that would be a saturated amount. Okay. But what if in my at 20 degrees I try to dissolve 90 grams of calcium chloride? Well, when I'm above the curve, there are two options. Okay. If it all dissolves, then I'm going to be supersaturated. Okay. And that means I probably had heated up and then cooled it down. But if it does not all dissolve, then I would just be saturated with some on the bottom of my beaker or cup or whatever that would be. Okay, and so that's kind of how we would read a graph. So below the curve is unsaturated. So under the curve, unsaturated. Anything above the curve and falls out of solution or stays a solid, okay, is considered a saturated solution, or it stays dissolved and it's called a supersaturated solution. And remember that negative slope is an indicator that we have a gas present because as temperature increases, the gas will no longer stay soluble. So let's look on some problems. Well, gave you one already, but we see if we have 70 grams of KCl and 100 grams of water, which notice based on our units in our graph, they're all in 100 grams of water. Okay, you have to keep that constant. And it's heated to 100 degrees Celsius and then cooled to 60 degrees Celsius. And all the KCl is dissolved. What kind of solution is this? Well, let's use our graph to help us. So KCl is this orange line here, okay? And it says we have 70 grams, which is right here, in 100 grams of water, and it's heated to 100 degrees. So at 100 degrees Celsius and 70 degrees, we've got a spot right there. And it's above my line, okay? It says it's cooled to 60 degrees. So that means we stayed with our same amount, but now I'm at 60 degrees. So I'm still above my curve, okay? So I'm above the curve, which gives me two options. It could be supersaturated or saturated. Now, they tell us that all the KCl is dissolved. Now, if all of it is dissolved, that means it will be a supersaturated solution. Okay, a saturated solution would still have some solid left undissolved. Okay, now while I accidentally gave you the answer here for this one, let's go through why saturated is the answer. Okay, it says a student adds 60 grams of KClO3 to 100 grams of water at 50 degrees Celsius and stirs. Okay, so if we have 60 grams and at 50 degrees, that would be a dot right around here. Okay, well that is above my curve because KClO3 is referring to this purple line here. Okay, it's way above my curve. And they say that she just stirs. There's no mention of heating it up and then cooling it down or whether or not it all dissolves. So the only thing you can assume is that it is a saturated graph. In the next video, we'll talk about how to actually create a solubility curve. We'll be working on them in class, but you'll also see this type of graph and maybe even have to create one yourself on the Gateway.